everyone, and welcome to a lesson on arithmetic sequences. If you're wondering what arithmetic sequences are, they're just a series of numbers, a pattern that either changes by addition or subtraction. But if that definition doesn't work for you, then how about I give you a more visual example? And that's with these stacks of coins. We can see that they're going 2, 5, 8, 11, 14. So we have 5 stacks, and they're clearly following a pattern. But what could that pattern be? There's like a huge hint with the red coins. So what if I was trying to figure out how many quarters there would be in like the next stack of numbers? Well, that could easily be found, right? If we just see that these are going up by plus 3, plus 3, plus 3, plus 3. So I could just take 14 and add an extra 3 to get 17. What about for the next stack, the 7th stack? Well, then I would just add 3 more, right, to 20. And then what about the 8th stack? Well, then I would just add 3 more, and I can keep on going and going on and on. But this gets a little more complicated when I ask, what would be in the 100th stack? Do you really want to add 3 a bunch of times? Wouldn't it be better for us to just take a shortcut, perhaps? If we were going to take a shortcut, and we just jump to the 100th stack, what did we start at? Look at this. We start at number 2. We're adding 3 a bunch of times. So can we just add 3 100 times? And a lot of you are probably thinking, yeah, we just start with 2 and add 300 times. But think about it, guys. To get to the 2nd stack, how many times do we add 3? Once. To get to the 3rd stack, how many times did we add 3? Twice. To get to the 4th stack, we added it 3 times. So notice how we're adding 3, 1 less than whatever stack we're aiming for. So instead of 100, we would want to do 1 less, right? Which would be 99. So I could represent this as 2 and adding 3 99 times. And this kind of reasoning is the kind of reasoning that we want to apply today. We're trying to create these equations. So without further ado, let me show you guys that there are 2 types. There are 2 forms to this. We either do explicit or recursive. Now, what we like to do, guys, when we talk about these patterns with coins or numbers, so on and so forth, is we like to refer to the way it changes as D, difference. So whenever you guys hear about the difference, you can tell the difference in this case is positive 3. So the formula for explicit is this right here, guys. And it's what we just talked about earlier of just starting number plus how it's changing and then 1 less than whatever stack we're looking for. So when we talk about this stuff, guys, think of n as whatever stack or whatever position we are in the list. And this function starts with the very first one, n is 1, and then we add how it's changing to whatever we're aiming for minus 1 time. So an example would be for this equation right here is we start with 2 and we're adding 3 n minus 1 times. So if I was to ask for 100 minus 1 is 99, we would add 3 99 times. If we ask for 1,000, it'd be 999, so on and so forth. So that is explicit. And recursive, even though we didn't really talk about recursive is actually what you were doing earlier. What's the next stack? 17, because you took the previous answer and added 3. And after that is 20, because you took the previous answer, added 3, so on and so forth. So recursive represents that thought process of just slowly adding or subtracting 1 at a time. So it's represented like this, guys, where we have to say what we're going to start with. And to find any answer, we need to know the previous answer. That's what f of n minus 1 means. The previous answer, and add or subtract the change. So in this case, we know f of 1 is 2. And we also know that it's changing by 3. So I say we take the previous one, add 3. Now I know this isn't really enough, guys, for you to understand this. So we're going to go over one more example. Where we're going to create the explicit and the recursive form based on the example. So here's an example right here, 25, 20, 15, 10. The question is this really an arithmetic sequence? And we're going to find that out in just a second. But for us to make our explicit or recursive rules, we need to know 2 things. We need to know what is the starting term, and we need to know how is it changing. So we can see that the starting term is 25. So f of 1 equals 25. Boom. We've already done like half the work right there. The other thing we need to know is how is it changing? But look, 25, 20, 15, 10. Isn't that changing all in the same manner? Yeah, it's going down by 5. And remember, arithmetic sequences are for adding 5 and for subtracting 5. So we could say that the difference is negative 5. Boom, minus 5, minus 5, minus 5. Now, we have all the information we need, so all we have to do, guys, is to take the formulas for for explicit and recursive, and to fill in this information. So remember, explicit is this formula right here. So all we're going to do is we're going to take our equation and replace f of 1 with 25 and d with negative 5. So it's minus 5 right here. And then for recursive, here's our formula right here. Now remember, what we're going to do is while we take this, we don't replace f of 1 25. We say f of 1 equals 25. We're just flat out saying we start with 25. And to find whatever term we need, we took the previous term, and we're going to subtract 5. And that's how you make explicit and recursive, guys. We're going to practice with this a little bit more in class. But for now, I want you guys to try a few practice problems that are based on this. And that is it for today's lesson. So you guys have a good day. Bye.